Hey SM3, this is a video that will go over information about the project, the final project. So if you go to your Canvas page, so for my course right here, and if we just go to the home page or on modules, and let's go to Unit 1, whoops, I didn't add it there, so let's go to Assignments. Okay, and then let's go down to the project, final project right here. Okay, and here's a PDF of the directions. Okay, so the objective, you're going to use your knowledge of solids of revolutions to solve a design problem. And here's the prompt. A company is hosting a contest of who can create the best gift for them to sell. The gift must be a 3D object formed by revolving a set of functions around an axis on the graph. The gift can be anything you would like, a vase, a pot, sculpture, anything that you can be creative enough to work out. You will pitch the idea that you think would sell. So here are the requirements. So for the piecewise functions, you have to have at least 4 functions. 2 of them have to be non-linear. You need to include the domain for each piece and written neatly and clearly on a project. You need to have a graph of the piecewise functions. They need to be accurate, drawn neatly and large to scale. A 3D object, so state which axis it's revolved around. You can color a picture of it, accurate, be creative. And then there's going to be you're going to have to write a pitch to the company. So this is the only writing portion that you'll need. So in this writing portion, maybe like a paragraph or 2 long, you're going to say why yours should be the pick, why would consumers like it, what materials would you use, what dimensions will it be, how much will it cost, and how much would you sell it for. Professionally written and typed. So just be creative with that pitch. I'm not looking for anything that has to be like too specific or anything. And then of course you will present it. So we'll try and get the presentations done on the 20th. And if we can't, we'll do what's left on the 24th. And so if you need to present earlier, let me know. We'll see what we can do. Okay. Now, with that being said, let me show you what you can do with Desmos, because Desmos can be really helpful. So I'm going to design a cup. Okay. Now, for a cup, well, first of all, let me try something like this. Let me draw a quick just picture of a cup. Okay. Now, if I were to draw a cup like this, okay, so here's a cup, right? Something like that. Now the cup, if I'm going to design a cup something like this, so I need to identify an axis. A horizontal axis would not be helpful here. So I would need to do something more like a vertical. I would need a vertical axis. Okay. And so for my piecewise functions, let's go ahead and get rid of one side. So I'll get rid of this left side. Okay, so I need to revolve it around that. And so here it helps me identify the functions that I might need. Okay, so I'm going to need a function that, first of all, is curved, something like this right here. Okay, now also think about how a cup is hollowed out. So if I'm going to hollow this out, I need an identical function that goes up like that, and then this would be the lip. Okay, so this orange outline right here would be the outline of my cup. As I make these functions right here and revolve it around the axis, I will make my cup. Okay, so I think I've identified my functions. So what I'm going to do here is I'm going to make the bottom of a cup, it needs to be flat, like that. And I need a function that is curved like this. I need another function that has a flat line for the lip, and then again I need an identical function that goes like this. Okay, so these functions, I would think this one could just be a horizontal function, so y is equal to something, and same with this. This one just needs to be y is equal to give me a horizontal line. These two functions right here, this one would have to be maybe a parabola or even an exponential function. So maybe x squared or e to the x or something like that. Because a parabola looks like this. So if I cut it down the middle, the right side would give me that lip. But I think instead I'm going to go with an exponential function, which goes something like this. So I'm trying to draw on the iPad, and it's standing up on a stand, and so it's kind of difficult. But so let me show you how I would design something like this in Desmos. Okay. So let me first put together a let's say I'm going to go with an exponential. So let me type in the function y is equal to e raised to the x power. Now, I want this to be reflected over the y-axis, and so I'm going to need to move it more to the right. I'm going to move it 5 units to the right. And so if you guys remember your transformations, I hope you guys do, horizontal transformations occur with the x value, so and they are opposite. So if I need to move it to the right, I'm going to do -5. If I needed to move it to the left, I would do +5. So -5 right there. Now I'm going to need to shift it down, and so this has to be outside of the x value, x variable, and so since it's down, I have to do -5 in the y direction. Okay, so I have that going on for me right there. Okay, now I want this to be just a little bit more steep. I want the cup to be a little bit more steep, and so if that means I basically I want to vertically stretch this graph. So see how if I add 2 out here, it makes it more, it makes the cup more steep, and the larger I make this variable, it makes it more and more and more steep, if you can see that. So let me go with something like 10. But since I'm doing that, I think I want to push this out just a little bit more. Yeah, I'll do something like that. Okay. Alright, and so that's for this first function. Okay. Now, also we need to keep in mind the domain. So in the instructions it says that, so let's see, piecewise. So for the first requirement, includes domain for each piece. So I need to make sure that I am including the domain. So the red function, my function here, if I'm going to reflect it about the y-axis, it can't exist to the left of the y-axis. And so that's when x is less than 0. And so if I put a curved bracket like this, or parenthesis, I'm going to state that x has to be less than 0. So 0, there we go. So 0 has to be less than x, or not less than 0, x has to be greater than 0 if I want to keep it to the right. If I want it to the left side, then I could do greater than, and that would keep it to the other side. But the thing is, my function just is a straight line because it's a exponential, so that won't work for me. If something like a parabola, that would work, but not for this one. Okay. Next thing that I'm going to do, because I want the bottom of my cup to be flat, I'm going to try and make a horizontal line. So let me do something like y is equal to -4. Okay. Now that for me is a little bit too high of a line, so I can't do y is equal to -5 because the function, the red function, has a horizontal asymptote at that. So let me just do something like 0.5, or let's say 0.75. I can even do 0.9 maybe. Let's do 0.8. That one looks good. 0.8. Okay, so now again I need to make sure that I don't have the functions where I don't need them. So right here I'm going to click on where these two functions intersect. Okay, so the x value is what's important. So on the x value, they intersect at x equals 4.088. So that's where I'm going to list my domain. So for this y function, this horizontal line, now it has to be greater than 0. Okay, so let me put that. It has to be greater than 0. So 0 is greater than x, or less than x, so that way it takes it away from the left side. But then it has to be, x has to be less than where the intersection occurs, so that's going to be at 4.088. So you see how I restricted the horizontal line to where they intersect. Now that also means up here that I need to change where this function goes to, and then again where they intersected at 4.088. Okay, so you see right there. And I'm also going to do equals. Okay. Yeah, there we go. Okay, so you see how I don't have any excess lines. Okay. Alright, next thing, I need to identify where I want the lip to be. So let's say I want the top of the cup or the lip to be at, see, I can make another horizontal line at y is equal to 8. So like something like that. Now again, let's see where they intersect. Like if I point there, the x value is where I'm interested. So the x value where they intersect is 8.262. Okay. So then this green function, I want x to be less than that, because then it will cut it off to the left. So let's do x has to be less than 8.262. Okay. And then the red function also has to be less than that value, so it has to be less than 8.262. Okay, so you see how that works out right there. Now I need another function that is similar to my red function. So actually, so if I take that same function, so y is equal to 10 e raised to the x, I have to be careful about this one, because if I do x minus 8, it's just, oh wait, no, x minus 8 is good, but then the vertical shift, I can't just do minus 5, because that's going to be the same function, so I want to be more than 5, so let's do minus 4. Okay, now that's a bit thick on the bottom, so I'm going to do minus 0.5. Yeah, I could do something like that, 4.5. That's fine. So 4.5. But notice how it kind of, it doesn't keep the same thickness throughout. So I need to change the steepness of this purple function right here. So if I do that, let's say if I change this to 11, so you see how it changes the steepness of it. Okay, so let's do something like 15. Generally keeps the same thickness right there. Okay. Alright, now here let's see where these functions intersect. So they intersect at the x value of 7.818. Okay, so this purple function I need to restrict. So right here I need it to go from x equals 0 to this intersection which is 7.818. So it needs to go from 0 to 7.818. Okay, and now all that's left is to restrict this green function from the same value. So, and then 7.818. Okay, and there you have it. I have 4 functions. I have this blue function, which is a linear function, straight line, and then the green one, which is also a straight line. So those are my 2 linears, and then I have 2 non-linears, the red and the purple, and this will make my cup. Okay? Alright, so hopefully that gives you an idea of something. Again, be creative. Doesn't have to be too complicated, though. Try to not make it too complicated. Try and keep it as simple as you possibly can with being creative, because more complicated, the more lines you get, it might get pretty messy. But let me know any ideas that you might be struggling with. So if there's any ideas that you want to design but you can't quite get the design that you want, let me know and I can do my best to help you guys. Okay, so I think this will be a fun last thing to do. The project is going to be worth 100 points, which is a good portion of your grade, and it will really help you out. So yeah, let me know if you have any questions.